So in my last video, I could not show you my solution code due to the length of the video has exceeded the limit of 30 minutes. So let me quickly walk you through my code. So this was the code which I submitted in the contest. As you can see, I think I have explained up till here, like I am marking all those integers which are prime in this p of I. So if this p of I is 1, it will be marked as a prime number, and thus we will be pushing it into the primes vector. Okay. So now let's quickly have an observation. So the first three primes, 2, 3, and 5. So the sum of their squares is 38, right? So if our n is less than 38, then definitely we are not gonna have any pair of ABC, right? Next, just remove 4 from the original, uh, just remove 4 because one of the primes will be taken as 2 so as to make the sum even, right? As I have told in my previous video. And this flag is for like if we have found the other two number pairs or not. So I iterated through this whole primes vector. Basically, this FL has been defined here. If you can see, here it is. So it is basically a for loop running from I equals to A to B. So sorry, A to B minus 1. So in this primes vector, what I am taking square of the mm, the square of the current number, and if it is greater than n, then I will obviously take out. And what is the required, like as I have previously told, we have our a as 2 and the b is primes of I, and what will be c? The c square will be this required, right? So this required we are considering as c square. Now we just need to check whether it is this required is a perfect square of a prime number or not. So how do we check? So for checking a prime number, what do? We will just uh, check with this array, the array which we have marked initially while doing this sieve, right? And for checking whether it is a perfect square or not, I have taken the square root. So if s into s is equal to required and s is greater or equals to 3, s must not be 2, right? Because we have taken 2 as a. The three digits A, B, C we need to find, right? So our A is 2 already. We need to find B and C. So our B is this primes of I. So what we are checking if P of S, that is S is a prime number or not. What is S? This C, right? This required is C squared. So its a square root will be C. So sorry, if its a square root will be S. So this S is marked as C. So we are checking if it is a prime number or not, and S is not equals to primes of I. What does this mean? B is not equals to C, right? So after all these conditions, if all these conditions are satisfied, then congrats, we are having our three prime numbers whose sum of squares is equal to n. What are these numbers? 2 primes of I and this S, right? So we marked our flag as 1 and we break out of the loop. So if we haven't found the triplet, we will mark no, we will output no, or we will print yes. So yeah, that's it for this problem. I will make a video on the sixth problem as well later on sometime. Now it is getting too late, and so yeah, thank you.